Hello, everybody. For those of you I haven't met yet, I'm Dean Rebecca Thomas, and it's my pleasure to welcome you to today's Academic Affairs presentation. This is a collaborative project team that is funded by the DLA for at least part of the project, including Professors Kenneth Mooreman and Geoffrey Williams, as well as Darrell Corn, class of 21. Their project, Reconstruction Newspapers, a computer vision approach to analyzing the past. I'm happy to turn it over to Darrell.
All right, thank you. Hello, everyone. My name is Darrell Corn. I graduated back in 2021, and now I'm back with Dr. Mooreman and Dr. Williams to present this research that we've been doing on Reconstruction Newspapers. It's a computer vision approach to analyzing the past. So a quick summary of what we're doing. We're using machine learning algorithms to analyze all historic American newspapers. And then we plan to track American sentiment relating to African-American civil rights over time. And the reason I'm working with the professors on this project, because I'm interested in sort of data science-y stuff. And for that sort of path, you tend to need personal projects under your belt to kind of show what you've done and what you can do. So this is a great way to do that. And without further ado, I'll get into what I have in store for you all. So this is the outline of my presentation for you all. We're going to start with kind of what inspired our project and how we began. And then I'll talk about the sources we're using for our data. And then I'll also talk about some software we're using for our research, because as I mentioned, it's kind of machine learning, deep learning, data science heavy. And then I'll just discuss some code refinement that we do that I find pretty interesting. And then I'll cap it off with some lessons we've learned so far. And I say so far because we're not quite done with our project yet. We have yet to obtain our final results. But I think it's still pretty interesting what we've done so far. So I'll talk about everything up until that point. All right. I also wanted to express our gratitude towards Transylvania's Department of Digital Liberal Arts for giving us funding, without which our research here would not be possible. So thank you. Okay, so our project begins when Dr. Williams hands me this article here, titled Gendered Language on the Economics Job Market Rumors Forum, written by Alice H. Wu in 2018. And what Ms. Wu did here was she collected these economic forum posts, and she pulled out from these posts words that strongly were associated with discussions of gender. So posts that were talking about like female and candidates, employees, and male candidates and such. And she found a disparity between the types of words that were typically used. With posts that were discussing female candidates, they were mostly about physical appearance or personal information, whereas posts that indicated they were discussing males were more so about academic or professional characteristics. So a bit of a disparity there. And I think Ms. Wu's work here is very important and very interesting. And one of the reasons that we found her work very interesting was the method she used to gather her data here. So she started with just these online forum posts, right? But she was able to consolidate all of that and pull out measured analytics. And I find that idea fascinating of pulling out quantitative data from qualitative data. So we decided to use this approach on a different data source that is mentioned in this book here, titled The Death of Reconstruction. Now, this book, written by Heather Cox Richardson in 2001, depicts or makes an argument for Northern support waning during the Reconstruction era. And the Reconstruction era, for those who don't know, it's Reconstruction with a capital R, and it is a period immediately after the Civil War up until about 1877 or so. And it's where our country kind of grappled with the questions of how to redress the inequities of slavery and how to readmit the 11 seceded states. And this was known as a very optimistic time for African-American civil rights. But towards the end of the 1870s, the more progressive and radical ideas for this movement begin to wane. And to the point that around the turn of the century, the South had pretty much a new system of disenfranchisement and segregation towards their African-American citizens. And we kind of know this as it culminating, or at least ultimately expressing itself as like the Jim Crow laws and such. And Richardson's book here argues that class, along with race, was critical to the end of the Reconstruction era. This is just one of many theories for the ending of the era, but yeah, it's a solid one that we are going to pursue in our research. So when we put these two texts together, we get this research question here. How did American views towards African-American civil rights change from 1865 to 1900? And we are going to take a computer vision approach to answering this problem. We could go the route of Heather Cox Richardson and hole up in some archives and read through manuscripts by hand. But we are computer people, that's not our forte. And the way that we're going about it is it's going to let us analyze millions of texts, whereas that wouldn't really be possible to do it by hand. So there are trade-offs to our approach and the more traditional approach, but we still think we can pull out pretty detailed and insightful answers to our research questions by going about it this way. Okay, so I've mentioned machine learning quite a few times already, so I figured I'd better explain it a bit more. And it's a huge topic that I don't really have time to get into, but Arthur Samuel here, who was a computer scientist in the 1950s and kind of pioneered machine learning, he explained it pretty succinctly here by calling machine learning is the field of study that gives computers the capability to learn without being explicitly programmed. So you have these machine learning algorithms, right? And you feed them data so that they can sort of self-optimize and arrive at very accurate predictions. And these predictions are probably more precise than what we could do by hand or find out on our own. And of course, there's lots of different machine learning algorithms for different problems and such. And when you start to get into this, you realize that machine learning typically always follows this path that I've laid out here. And it definitely outlines our research. So I figured I'd go through it with you all. Machine learning algorithms, when you're making one and using one, it always starts with data collection. So we need to collect our newspaper data in order to train our model. Then you need to sort of prep your data. So typically you need to clean it up a bit. Sometimes you need to transform it so that it's in a slightly different form and your model can learn from it better. But you always need to split your collected data into test and training data sets so that you train your model on about 85% of your data, and then you test it out on the other 15 to see how well it's working. How well it's working. Once you've prepped your data, and you're ready to start training your model, there are two different categories, I suppose, that tend to emerge regarding machine learning. There's more traditional models, which are relatively more simple, and they are much more standardized. They work out of the box, and you can pull them down from math textbooks and such. And they're just not as complex, really. What we're using more so in our research are the deep learning models, and these are relatively more new, but they're definitely more complex. They're comprised of multiple layers of calculations, and they are built more towards their use case, so they're a lot more specific than the traditional models. But deep learning models are driving a lot of the current digital innovation that we see nowadays, such as ChatGPT, that's built on deep learning models that allow it to mimic human behavior and such. And also Tesla's self-driving cars use deep learning to stay on the roads. And also facial recognition is using deep learning. So once you're done building and training your model, you are ready to evaluate it to see how well it's working, which is always a fun step because more often than not, you start and it's not working too great. And then you have to go back through and retrain and make more data and such. But once you're happy with how your model is working, you typically want to tune it a bit to make it a bit more precise before you finally deploy your model. And that's just the industry term for using your model, really. Okay, so when we started collecting our data, our team decided to use the Library of Congress to gather all of our samples here. And the Library of Congress has a lot of stuff. They have, well, what we're mostly concerned with are the historic American newspapers that are on the Library of Congress's website. And these newspapers, their publishing dates range from 1770 all the way to 1963. I don't know why 1964 was a cutoff date, but apparently it was. And they have almost 4,000 total publishers as well. And these digitized newspapers, they typically look like this, and they're pretty high resolution images. They are pretty big because they're like, 2 feet by 3 feet or so. And for our samples, if we select just for our date range, which is 1865 to 1900, we find that we get almost 1 million unique issues of newspapers, and a newspaper issue is comprised of multiple pages. So we have almost 5.5 million pages for our training data. So that's a pretty good training sample. We're definitely good on that front. Another aspect that makes the Library of Congress pretty useful for our research is that it has this image to text option. So we don't want to use the images of newspapers for our research. We want to actually use the text that's within the newspapers. But once we get to this point, we realize that we need to start thinking about how exactly we're going to take all this data and use it for our research, because we're not just going to go through by hand and download 5.5 million pages of data. Instead, we're going to build a computer script that crawls through the Library of Congress's website and downloads our data for us. And that such computer program is called a web scraper, or web scraping, which is the technique where a computer program extracts data from a website. And the benefits of web scraping are that they're super useful for collecting data from dense websites, such as like from the government or job postings. But there are some things you need to watch out for with web scraping, because people can have used them for malicious purposes. Not to make everything all dreary, but we've all heard of like web bots that can dominate online transactions, so they can scrape, they can snatch up ticket sales very quickly, or snatch eBay purchases quickly. And people use them to post on social media and such. But those are more annoying for people who are using the internet and browsing. But people who host websites, web scrapers impact them a little differently. So a web scraper is still pinging a website just as a person who's browsing, and this can result in taking up more bandwidth for of the website and kind of slowing down internet traffic, and it could crash the website if there's too many. And that's kind of what happened when Taylor Swift released her tickets on Ticketmaster. And one reason that website crashed, a lot of Swifties, snatched up tickets, but also people were deploying web bots to scout the prices. So websites, of course, are aware of this, and they build in protections against web scraping. If you ping a website too much, a little too quickly for what a human could do, they'll typically block you. And then you can't scrape anything, of course. In order to get around that for our team, we have to adapt to that. We are going to institute pauses and slow down our code, so that way we're pinging the website, say, once every 10 seconds, as opposed to 10 times a second. All right, once we get our web scraper up and running, we're able to pull down our code and see what we're working with here. And what our team found was that the image to text ability of Library of Congress really wasn't that stellar. In fact, it was quite unusable, really. So here's an example I have for you all. It's a chocolate ad. And we can see that the the image to text makes a lot of mistakes. And you can't fault it for everything. Some of the letters have scrubbed off in the 150 years since it was published. But it's also making some pretty obvious mistakes, such as the word on in the top right corner is being transcribed as and some obvious letters appear as punctuation in the transcription. So when our team saw this, we found that we couldn't really use this, and we're gonna have to take a look under the hood to see what's going on here. Now, this field of computer vision that deals with converting images to text is known as optical character recognition, or OCR for short. And that's, converting images of print into machine readable text. And OCR is quite prolific in our everyday lives. If you've ever used your phone to digitally scan a check, that uses OCR to read your handwriting. The postal office uses it to help sort their mail. And if you've noticed those license plate cameras that have popped up all over town, those are using OCR to, I suppose, read your license plate and check that you're actually driving your car. So now that we know a little bit more about OCR, we're able to ask ourselves, why is the Library of Congress's output so poor? And the most basic answer to this question is that writing OCR programs is hard, which I guess could be the answer to a lot of issues. But the OCR is known to never be 100% accurate, even on the most optimal data. And we're not feeding these programs optimal data, really. As we mentioned, this ad has some missing characters and such. But another reason that the output is likely so poor is that it takes a lot of time and resources to create strong OCR programs. And that's likely something the Library of Congress just doesn't feel the need to do, more or less. It would take a lot of incentive to highly improve this program. So the only company or entities that really do have the incentive and the resources to create such strong OCR programs are some of the biggest tech companies around, such as Amazon, Google, and Microsoft. So what our team decided to do was swap out the OCR from the Library of Congress with one of these companies' OCR programs. And we went with Google because really all three of them are about as accurate as each other. And Google is just the easiest to pick up and learn. So, sometimes you got to go the path of least resistance. And here is a comparison of the two. And we find that Google's output is a lot better than Library of Congress. It's not perfect, but it's much more usable than what we had previously. But when we get to this stage, it's not enough that we just have a better OCR program. And an example of this is right here. This is a picture I took for you all of two stories in the newspaper. And these old newspapers, they lay out their stories in columns. And when we feed this image to Google's OCR program, it just reads right across the dividing line, kind of like a child learning how to read, just reads across that seam of the page. And we realized that if we don't take into account the unique layout of historic newspapers, then we're still not going to have very good OCR output. And our team decided, in order to solve our computer, our algorithm problem here, we decided to implement another algorithm on top of it. And we need an algorithm that will detect the layout of these newspapers. That's where we use this program called Layout Parser. Now, Layout Parser uses deep learning to detect complex document structures. And it's built upon some Facebook research. And I think Layout Parser is pretty great because it's open sourced, which is computer speak for free. It's well documented by the developers, so I can find tutorials online. And the developers have supplied us with some pre-trained models as well. And the images I have of you are some of those pre-trained models. How we use Layout Parser to detect the layout is it draws these sort of boxes around the text. And we take those boxes and then we crop our image down to these individual stories. And we pass those images to Google's OCR so that it can't read across the dividing line anymore. The only downside to Layout Parser is that it is incredibly difficult to install. And I'm not kidding when I say it took me weeks to figure out how to do this. Maybe even months, not gonna lie. But with enough patience and persistence, I did get it working. And I found that that's just kind of how these
and then help the others.
and yes, and then helped the professors as well. I found that these open source community projects, they don't they don't have the incentive to really tell you everything of how to install them. So if you want to use them for your personal projects, it takes a bit of persistence to get them to work sometimes. And now while the developers supplied us with some pre-trained models, none of them really fit our use case. None of them were specifically trained on newspapers. So thankfully, the developers gave us some training uploaded some training scripts. So we were able to take one of their pre-trained models and then train it to our specific use case. And these images I have up here for you all are me creating some training data for our model. And how we decided to detect the layout of these papers is that the green boxes are the header text. So those are like article titles and such. The blue text are the actual stories themselves, or the body text. And the yellow boxes are some other kind of text, such as advertisements, images, or tables. And for our research, we're not concerned too much with the other category. We really just want to analyze the headers and the body text for our research question. And here is the output of our training model. Apologies for the colors I decided to use, but our output is pretty solid, really. The yellowish boxes are the headers, the pinkish boxes are the body text, and then the white or transparent looking boxes are the other category. And we can see that it's not perfect. So at this point, we would go back and train our model further by giving it more training data that would help optimize it. This wasn't the final iteration of our model, I swear, but it's what I had on hand for the presentation. Okay, so we've talked about everything through our workflow, and we're ready to start cropping our images down to individual stories and sending it over to Google. And at this point, we have to think about how much this is going to cost, because unlike the Library of Congress, Google is a private entity, so their services will not be free. So let's figure out how much this is going to cost. We know that for our date range, we have about 5.5 million pages of data. And after I did some math, I found that Layout Parser typically splits their images between 13 and 14 smaller images. And the way that Google charges is that for every 1,000 images you send it, it charges you $1.50. So if we take 5.5 million times 13.74, we divide that by a million and multiply that by 1.5, we get a grand total of $113,000. So yeah, this isn't great. We realized we had to come up with a solution to kind of optimize our costs here. And what we decided to do was, again, throw another computer algorithm onto the stack. And that's where we bring in Tesseract, or PyTesseract. And PyTesseract is an open source OCR engine, so it's free. And PyTesseract, their output isn't as good as Google, but it is better than the Library of Congress. So what we're going to do is we use Layout Parser to find the individual stories in the newspaper. And then we use this PyTesseract to OCR that smaller image and get some preliminary OCR. If that OCR comes across a keyword relating to African American civil rights, then we send that cropped image over to Google to get a better OCR output. And if it doesn't come across a keyword, then we just discard the image. So using our new workflow here, we bring down our cost to a much more manageable level. All right. Yeah, much better. Okay, so we've evaluated our model. It's time to kind of tune it and make it a bit more precise. And after you've read as many newspaper articles as we have, you tend to find that there are some common OCR errors that pop up. And they're not really OCR errors. It's more so just how these old newspapers are laid out. They often hyphenate their words and wrap the text to the other line to get this nice boxy shape that I guess was in vogue at the time. And you can see in this example here, words like ambassador, passengers, and present are all hyphenated to the next line. So we wrote some custom code to kind of mush these words back together so that when we do our keyword search, it's able to actually detect the word instead of not recognizing it at all. And one thing I wanted to mention that we are not doing is that we are not instituting any sort of spell check beyond this. And that's because we don't want to accidentally create some false data. We don't want to make these newspapers say things that they're not really saying. And an example of this is actually in this image that I grabbed for you all. So in the second to last line, the word positively is misspelled. And if we were to institute some sort of spell checking algorithm, then that would likely correct it to the correct spelling. But now our output is different from what it's actually saying. And so that's a pretty benign example of this, but it kind of gets at the larger problem. We don't want to cause too much of disparity between what it actually says and what we claim it says. So we're erring on the side of caution, no real spell checking. This part. So our work on our research is progressing steadily. When this article was published, led by Melissa Dell, professor of economics at Harvard, and what these Harvard researchers found was similar to what we found. It was that Chronicling America's OCR output is unusable, and commercial OCR engines are way too expensive to correct that. So they built a custom layout model like us, and then they built a custom OCR engine as well, and then they retranscribed all of Chronicling America and uploaded that corpus of text of improved OCR to the public. So when we read this, it was a little disheartening because now it feels like there are a lot of eyes on our research topic. So it feels like we need to focus and secure a topic for publication, which isn't a great feeling, but it's not all bad. There are some benefits to their research, and we found that their custom OCR or their layout model was better than ours, and also their custom OCR model was better than our Tesseract. So we were able to swap out our models for theirs, and now their research has improved our research really. But I also wanted to mention that their models were better, but that text that they released to the public, we found that we couldn't actually use it for our research because there were a surprising amount of errors in it. Oftentimes within their output, they would have a page that claimed to have data from one page, but it was actually from a separate page. So it said, the text was on page 7, but it was actually on page 8. And that happened often enough where we couldn't really trust the data, unfortunately. So while it was, excellent data, we couldn't use it for our research. And apart from that, we also found they were missing a lot of data as well. So they really only, a lot of their data was really only the first page of these newspaper issues. And after you've read as many articles as we have, you find that a lot of the issues have at least 4 pages or up to 12 or 16. So that was, there were a few samples missing there to the model. And of course, we reached out and let them know. I'm sure they were thankful for our constructive criticism, I suppose. But yeah, I suppose you can say that we've assisted with Harvard level research now. Okay, so all of that brings us to our current situation. We have a 16 terabyte hard drive in Dr. Mooreman's office, ready to store all of our data. I imagine we'll use every bit of it. We're about to scrape millions of pages from Chronicling America. We will then parse that text for some keywords relating to African American civil rights, and then we're going to analyze the sentiment around those words for a research question. And to cap it all off, I'm going to talk about some lessons that we've learned along the way. I myself have learned a great deal about machine and deep learning, just how to create these models and how to properly utilize them, something that has definitely helped me in my work already. We've talked about how to responsibly web scrape and have good internet etiquette. We've discussed the trade-offs of OCR and where it performs well and where it doesn't perform so well. And I myself have at least learned to be patient with install processes. It's nice when the developers tell you everything you need, but they don't have to. I've also found that code can be wonderfully free, such as the American Stories code, or it can be wonderfully expensive, like when you send Google way too many images. And we've also found that I guess our research topic is a pretty good idea because now there are a lot of eyes on it, and it's time to buckle down and secure our topic, I suppose. So that is about everything I have for you. I've talked about everything we've done to this current point. I'd be happy to answer any questions you all have. Yes.
Have you identified a tool for sentiment analysis, or will you also be building your own sentiment analysis engine?
Yeah, that's a good question. There are a lot of sentiment analysis tools out there that we plan to utilize. So, and they're pretty sophisticated too. It's a well-trodden area. So we'll use something such as Hugging Face or NLTK, if you're aware of this. Yeah, and yeah, we're messing around with it at the moment too.
Researching.
Researching, that's not playing. Yeah.
Maybe a trivial question, but why do you have to face yourself when you're scraping data from Library of Congress? What are they afraid you're going to do it?
Yeah, really. It's mostly just that if we send it too many requests, that can slow down the website for people who are using it. And yeah, if too many people are sending requests, then it bogs it down for everyone else. So it's just good internet etiquette to not do that. Yeah.
I'm curious if you've generated the text that you're going to be looking for and how you did that.
Generated the text.
In terms of your keywords.
Oh, sorry.
Yeah.
Yeah, so we have a list of words that we're going to be searching for. And so it just it takes our OCR and it splits everything on the spaces of the words. So it finds all the individual words. And then if it matches up the words, then it says that's a keyword, and we're able to use it in our pipeline.
So I guess my question is more like, how did you choose the keyword? Like,
Oh, how did we?
You know, authority you went to, or brainstorm.
Well, that is one of the in progress sections. I don't think we've really finalized a section of keywords quite yet.
We're working on a keyword methodology, though. That's where I'm off on it.
Right, yeah.
One of the things that we got off on a side project is we collected 9 U.S. history textbooks from the 1800s. And we ran them through OCR and we pulled out the data from those. And we're trying to find interesting occurrences of phrases to get a sense of what textbook publishers of the time thought were important ideas to present to the American public school system. And that's where we're hoping our ideas of some of the text will come from.
Yeah, it's been a solid side project to our research here.
This is going to be in by hand. I mean, we looked at a little bit of time actually using our motion, but yeah,
Yes.
Okay, so I heard you say, I'm going to make sure I heard this right. You're using a sentiment analysis device to make sense of this.
Yes.
Because historians take years of training and immersing themselves in a discipline, and particularly in a period, in order to understand the meaning and context of words, which can change quite differently from what we understand
Right.
to what they were then, as well as not only understood definitions, but also informal understandings, right? So it's immersion in culture. So I'm curious how a sentiment analysis device can duplicate that.
Right, yeah. As Dr. Mooreman just said, one approach we're taking to that, because we kind of realize that things have changed over time, and so a current sentiment analysis might not really reflect, these 1800s newspapers. But we are going through these 19th century textbooks to try and get an idea of how people thought about certain subjects to better gauge, the real sentiment of time. But additionally, it's sort of one of the trade-offs that we have with using a computer vision approach to this instead of going through it by hand. If that answers your question.
Yes, it does.
And we don't know the full range of text that these models have been trained on. But as we said, we're pretty sure that they're trained on more modern things, which led us to the textbook approach. But we did think it would be interesting, as another side note, if we only had unlimited time, would be to see if you could produce a sentiment model for different periods of time, different periods of different eras of the world, etc. Because I think what we're dealing with right now is pretty much sentiment analysis as it would be today. And we need to modify that to get meaningful things out of it.
Yeah, there's a huge difference.
Oh, yeah.
And the other thing is, it'd be interesting to see the difference between a machine understanding, if the extent that the machine actually understands anything, because it's just generating text which has no input to the machine, versus a human understanding of something, which is could be an interesting split.
Yeah. Yeah.
So, I was on sabbatical last semester. Last month. Yeah, last month. Yeah, but I worked on auto, and one of my sabbatical idea was to read 5 volumes of Audubon's ornithological biographies, which is thousands of pages of text. So I got through 2.5 of those volumes, decided to do this route.
Okay.
So one of the things that I ran into, besides all the hyphenated problems that you talked about, I'm using R to sort of analyze this,
Okay.
was the sentiment problem. Because
Yeah.
a word that we think of, they have emotional words like that code for sentiment, but as you all know, phrases are different. Those words and phrases are different. And I was wondering how, if you just say, I'm going to find out how many times they say hate, that's not going to really help you, because you got to know what that hate is being used for in a sentence. So
Yeah.
can you speak about how you're going to take that sentiment word and expand it out to a phrase?
Yeah. So
Let Geoffrey.
yeah, you're
So partly, I mean, we're kind of looking, we want to answer in part to some of the things, kind of that thing. I mean, we're kind of looking for mathematical averages over the text involved, which I guess is going to give us, like, again, more of a 30,000 foot big picture summary view of it all. So we're going to be looking, we're looking at like broad patterns and like these words being used versus those words being used there.
But just single words or words that associate with other words?
The combination. I mean, certainly starting off with like the use of negative word, negative words being used. So a target word like freedman, free slaves, Negroes, whatever. And look for patterns of the words within range, within like 3 words, 10 words of whatever of those, and just see the overall sentiment. Because some of that is going to change, some of that won't change. And so looking, using kind of at the most basic level, as a preliminary sweep, looking at how those averages change over time. And then, so we're again, so it'll be less about understanding the phrase itself and more about how concepts and tones and concepts spring up and then go down over that 35-year period. So for example, the Heathercock-Richardson thesis is that certain concepts showed up in the context of freedmen, of like basically free labor concepts, the idea that they would be able to go get jobs and be able to work to basically be smallholders and develop in that way. By the end of the period, there was a lot more concern about like industrial work, like basically people had less of a model of these smallholders with their own farms, whatever, and more of a model of industrial workers who might be unionizing and protesting and kind of that, and there might be labor activism. So we're generating our thesis from the standard word. And so looking at how these concepts change, so you start to see like communist, socialist, organization, like labor show up more, and like smallholder farmer show up less. That'll show a balance of how the perspective changing will be part of this. But it would be, so on the phrase level, we're not going to have a huge understanding of any particular phrase, but the sort of the frequency of certain concepts and how those frequencies shift over time is more what we
Yeah.
So about to say, so, yeah, I find it interesting, but so you haven't actually, I know you're in the beginning here, but I think part of this, once you go through this, right, you're gonna eliminate 5.5 million pages down to I'm gonna quote here, manageable number of pages in the first place,
Yeah.
right? So I would assume then that you can then rewrite the programming. I mean, in other words, you might be able to do more of a sentiment analysis when it's not trying to do 5.5 million pages worth of material, but once you found something, we have this many articles, right? You could theoretically create something that would scan the whole article for a tone or a sentiment. That it would be hard to do now when you're scanning 5.5 million pages of everything. But once you get your boxes of data, you can theoretically change your programming and your learning, right? To look for
Yeah.
different sentiment type of thing.
That's a pretty good idea, really. We'll definitely have to look into that once we get
You
to
don't,
that
you don't
stuff.
want to do that probably with 16 terabytes.
Yeah.
Probably write a very, to their point, right? It'd be a lot easier to write a program for the words surrounding this word when you only have gigs of data as opposed
Yeah.
to, yeah.
Yeah, we'll have to keep that in mind.
Not to keep pushing on sentiment analysis.
Interesting part. Or I didn't touch on.
So this thing, I've been out of it too long to know. Last time I looked carefully at sentiment analysis and it was an LTK, it was mostly tweet level,
Okay,
right?
yeah,
So looking at the sentiment of a tweet is one thing, looking at the sentiment of a paragraph or
Right.
an article is very different. Do you
Mhm.
know or? is
And
how-
LTK, so I've been working a lot with LTK, which is a
Okay.
very much a blunt tool, I would say, but it is very helpful in terms of just looking for the frequency of, I mean, just in broad strokes, it's very cool. So you can sort of see like, okay, this word is associated a lot with a good tone, this word is associated a lot with bad tone. So the idea of kind of training, I think probably a stage that would make sense is training something using a hiding face method, using a deep learning method to sort of look for a more localized 1865 to 1900 tone, and look at, I mean, basically triangulate off of the paragraph overall. But I think probably sentences would be a good unit of observation to work off of. But yeah, the LTK is definitely the beginning, not the end of that process.
And we started to look at the comparison between what NLTK gives us as sentiment as opposed to what the Hugging Face model is. And Hugging Face is a great repository of all these deep learning models, and it has multiple sentiment analysis models that we've been playing around with, researching some and we did, interestingly enough, talk about that the paragraph level is probably where we'd like to be, but we don't think any of the models supports that level rate.
yeah.
Yeah, I'm also curious about sentiment. My question is, basically whose sentiment will be captured. So two things that come to mind are, one, this particular newspaper is being more of an elitist perspective on things, and then also the potential geographic disparities. So I'm curious to hear thoughts on that.
I think at this point, we hadn't taken into account, how these newspapers do come from all 50 states, I think some territories as well. So that could be another level to add to it. That would be interesting to see like how North differs from the South and whatnot.
I think a lot of that's like. Now I do think, so I think I guess one of the general point is just, there's probably multiple passes, probably simplistic kind of count certain frequency passes, and then more deep learning passes. What's interesting is you are able to, we give them the, like, you can get his application of a publication of each of these newspapers. And I think that story, particularly the change of views in the North, is going to be pretty interesting. The issue of the elite, of it being elite opinion, and there's a mixture of African American newspapers, but the rule of the white newspapers, like a white audience, white writers, writing for the white audience, is definitely, it complicates things. But so I think one thing is each newspaper has a certain point of view, which has been very striking, trying to control for that. Like this newspaper has this perspective, and kind of look for the controller for that point of view.
It's also been interesting to note just how many towns have their own newspapers. So it's not like today where you have a few companies pumping out these things. And through blind chance, some of our early articles that we pulled out and were trying to achieve a ground truth when we were doing the initial OCR had some fascinating articles comparing the lynching of freedmen in the South to the Spanish Inquisition, and talking about how this is a cheapening of what we should be doing as Christians. And lo and behold, that was a northern newspaper that was talking about that, looking at the southern activity thing, well, this is wrong.
Also a great presentation.
Thank you.
Yeah, I'm gonna echo that. I don't have a sentiment question.
Thank
you for the softball question, but as you all kind of define the model and start to apply it to different use cases, have you all considered like a local public-private partnership with somebody like a Visit Lex that has a tourism publication from now until back in the early 1900s? It would be kind of like an anchor publication that would change sentiment throughout, but be consistent in presentation to some extent, which would also help your funding problem.
Yeah, it's fun. No, we haven't really considered that, but that would be interesting to explore. Yeah, like a local partnership of sorts.
Yeah.
Yeah, that could be interesting. Yeah.
I guess going back to the keywords, from the examples you showed up there, none of the OCRs were really able to transcribe the newspapers perfectly. Like I know, like none of them were really able to get the first word of it. Right.
Yeah.
So with your keywords, there's outgoing examples where the keyword appears, but like they misinterpret one or more letters. So is there something in your model that can account for that? You know, look for this keyword, anything like really close to this keyword, or is it just hoping that enough other context supports correctly if you're near it that you can find it?
Yeah, that's a good question. I would start with, that is one of the trade-offs we're making, where it's not going to get every single one likely. But we've found as we go through these by hand that usually they have the keywords mentioned multiple times in these articles. So that helps to give us a higher chance of recognizing one of the keywords. And apart from that, I suppose as we go through our keywords, we might, institute like this one isn't the exact keyword, but it's close enough. We might do something like that as well. Yeah, but it does come down to it's one of the trade-offs. We won't catch every single one.
And one of the reasons that they roped me in is my area is natural language understanding, and there is an amazing amount of redundancy in human language. And so that's what led us to this path of using a not great OCR as the first pass. We know we're going to miss stuff, particularly the first words, because there's usually that wacky capitalization. But we should be able to then, because of the redundancy issue, still see that, yes, this article is potentially interesting, then ship that off to Google and get a much better translation. Right. So yeah, human languages rely on that redundancy. And that's what we're hoping to leverage off of.
Yeah.
Not to add to your to-do list, but do you have any intent down the road to kind of distinguish between opinion pieces or editorials versus hard objective news? What's intended to?
I believe the Library of Congress captures that, I think, and they categorize them as one or the other. So
you
yeah,
get that for free.
yes, we get it for free. Yeah. So that would be interesting to incorporate as well. Yeah.
I think one thing there's also a lot of, like, so one thing that's happened a lot is like an article shows up in one paper and then it sort of shifts to another paper that republishes it just to save on. But yeah, like here's something interesting from our colleagues 2 books or 3 days away. So that.
Yeah.
I guess I would encourage you to continue to think about the biases of the sources. In part because this is the Chronicling America is an ongoing project.
Right.
So there are still newspapers being scanned by libraries and added to the Library of Congress, the big database.
Yeah.
So the ones that got done first tended to be what we think of as mainstream, the privileged, the white opinion. And now they're moving into the smaller communities, the African American papers, the papers that may be an entrance group paper. So that may be something that you want to pay attention to as you're analyzing that.
Okay. Yeah. We have noticed just in our time working on it that the number of issues keeps growing. I think actually now I said 5.5 million in the presentation. It might be closer to 5.8 million now.
I thought you had that number.
Yeah, it's definitely still
Down
growing.
the road, are the local folks who are feeding, who are scanning, feeding papers into that project.
Okay.
And they're still working.
Okay. Interesting to get more local newspapers on there, yeah.
Thank you. Yeah.